Добрый день. Слышно ли меня?
Да, я вас слышу.
Очень тихо. Сейчас попробую включить наушники.
Слышу вас.
Мгм.
Вас слышно хорошо. Вас хорошо слышно.
Да, да, спасибо.
А меня слышно?
Да, 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 слышно.
Здрасте.
Здравствуйте. Да, никто ничего не говорит. Эхо сейчас нет от меня? Вроде бы нормально слышно.
Да, нормально. Эхо нет.
Что я на всякий случай включил второй лэптоп, чтобы одним глазом смотреть в чат, а другим на слайды. Но, кажется, никакого короткого замыкания не произошло.
Ну, если там звук отключить, так чего?
Ну, в теории это должно работать.
Ну да, там на самом деле просто надо как-то правильно звук отключать. Я тоже не всегда у меня это получается.
Да, вот сейчас возник какой-то шум.
Да, а это у тебя, да?
Не знаю. Нет, вроде бы все.
Нет, ну ты говоришь, вроде бы шума не слышно, а это может быть кто-то подсоединялся и была какая-то проблема.
Саша, никто ничего не говорил. А вы скажите что-нибудь.
Коля, тебя было плохо слышно. Тихо.
Казачинский плачет. Казачинский ругается, что он ничего не слышит.
Ну, вообще-то молчат люди в основном.
Да, я понимаю.
Он это давно писал на самом деле же.
Похоже, что он в самом деле не слышит. А нет, теперь слышит.
Нет, теперь, кстати, я тебя гораздо лучше слышу.
Ну, я микрофон погромче сделал.
Да, понятно.
Вот какой-то шум от Николая Константиновича идет. Нет. Откуда же он идет?
От меня шел, от меня. Это я признаю. Я сейчас выключу на всякий случай микрофон, чтобы больше не было такого безобразия. Андрей, а Шень там за стенкой или где
Нет,
он?
нет, Шень должен быть дома. По крайней мере, за стенкой его точно нет.
Мгм.
Алло?
Да.
Да. Okay, yeah, so I see Bruno is here. So we should speak in English.
Окей.
Yeah,
And also, I think we can start.
good.
Okay, let us start. So, yeah, you see the title of the talk. This talk was just the idea to give this talk was proposed by Sasha Shen, and in fact, I think almost everything that I'm going to discuss today, we know since 2002 to 2003. Just at some moment last year, at some moment, Sasha insisted on. He required me to explain him the arguments that we will talk about, and under his pressure and with his participation, these arguments were a bit simplified. But it's quite possible that some of you have heard all these stories, and if you have this deja vu feeling, it's okay, it's normal. Okay. So there are two keywords in the title: clusters and information distance. The information distance, the definition of information distance goes back to this famous paper of 5 authors: Bennett, Gach, Lee, Vitani, and Zurich. Well, here's the version of the definition that we will take the principal definition. It's just the maximum of two conditional complexities. It's a distance about two constructive objects, or let us say between two binary strings, and it is just a maximum of two conditional complexities. I will say all the time distance, information distance, but technically speaking, it's not the real distance because the triangle inequality is valid only up to logarithmic term. And if you want to be very precise, then also the property that this distance between x and x is equal to 0, well, it's also not literally true. The distance between x and x is some constant, something very small, because conditional complexity of a string given itself is very small. But formally speaking, it's not exactly 0. So it's 0 up to an additive constant. It is, of course, symmetric. And the triangle inequality is valid up to an additive logarithmic term.
And probably if we use prefix complexity, it would be triangle inequality will be up to a constant. but this is not important.
Yeah.
Yeah, and we
right.
can fiddle a bit with the definition so that all axioms are satisfied, like artificially define it 0 for XX and so on. And so all these complaints can be addressed if needed.
No, but
It's just-
it won't give anything reasonable because
Yeah.
we can make the clusters then, but not really. I think helps.
What are the nice, funny property? It's not terribly difficult result, but kind of unexpected at that time. The distance can be defined in almost equivalent way as a length of one program, such that this program translates x to y and y to x. So in my definition here, it's actually maximum of lengths of two programs. One program, P1, translates y to x, and another program, P2, translates x to y. And in the alternative definition, it is one single program which can do both the jobs. It can translate x to y and y to x. And
also, there is a more subtle detail. One can also consider the program which transforms x to y and y to x, but it should be told this one bit in which direction it works should be communicated. And here, even there is no this additional bit.
Yeah, Sasha is right. There is the third definition where program takes x and I don't know, bit 0 and produces y, and takes y and bit 1 and produces x. This is another version of this definition. And it turns out that the distances, or these quasi-distances from all these definitions are substantially the same. The difference is bounded. Okay, if we take the plane Kolmogorov complexity, the difference is only logarithmic. So if at some moment we need a different intuition, we can switch from one of these definitions to another. It's all formally speaking, it's they give the same value, but we can think of it in different terms.
Okay,
So-
even with O of 1 precision, but that's unimportant details. They're all three equal with O of 1 precision for plane
Even for
complexity. Yeah.
the plane complexity.
Yeah, but not for the prefix complexity. So it's
Not for
something
complexity.
strange there.
Okay. Well, you see in this list of authors Vitani, and Vitani uses this definition as an inspiration for a series of semi-theoretical and semi-experimental works with different co-authors, with different students, where they were trying to compute and to use this distance for different objects from the real world. Of course, Kolmogorov complexity is not computable. So in the real world, we cannot compute this theoretical distance, but they approximate it using different practical text compressors. Also, they have also a different approach based on a priori probability, but their first idea was just to use, instead of the real Kolmogorov complexity, the minimal length in terms of some specific text compressor.
No, to be exact, he used not the I think, if I'm right, he used not the conditional complexity, but the complexity of pair.
Yeah, he uses complex. So here uses this relation that complexity of conditional complexity is complexity of pair minus complexity of the condition, okay, approximately. And then they were saying that, okay, let us compute complexity of a pair of files or one single file using the compressor zip or some compressor specific for genetic sequences. Also, okay, if we want to be very technical, they use some normalized version of this distance, but let us ignore these details for a while. And I'm going to show you with minimal comments a few pictures from their works. So here they use this kind of distance to compute the distance between the same text written in different languages, and somehow estimate the distance between different languages. And when these the raw data that they compute, they have a lot of objects that are text in different languages, and they estimate the distances between pairs of these objects. And then they use some standard techniques to construct a tree such that in this tree, in this binary tree, the objects that are close to each other in the sense of the tree, in the sense of the graph, have a small information distance, and vice versa. And this is interpreted as a kind of phylogenetic tree for these languages.
It would be interesting to find out whether it coincides with no, it probably mostly coincides, but whether there are some funny, subtle, distant, strange things related to some deviations. But I don't know.
Okay,
languages
you see here Estonian and the Finnish languages are close to each other, which is probably correct. These Celtic languages like Welsh and Irish and Scottish are close to each other. And I guess there must be some bunch of Slavic languages and Romanic languages. Okay, Slavic languages I see they are here.
No, it is interesting. What would they say about Moldavian and Romanian language, which just differ by the.
Okay, Romanian is here, either in Moldavian.
No. They are actually differences. Only they use Latin and Cyrillic letters. So what would the system give for them? Would they capture this or not?
Okay, you're so sure. Can you read or speak at least one version of this language, Romanian or Moldavian?
No, but
then you claim that they are the same. It's not very convincing. Probably it's true.
No, it's more or less common knowledge. But okay.
Not all common knowledge is true. You know, we should ask Mario Zimond about it. Okay.
Okay, but then I can ask about literally Serbian and Serbian written in different orthographics, which are both used in Serbia.
So do we have Serbian and Horvatian?
I don't know anything.
You see, Serbian and Croatian. You see, there are two languages.
Yeah, but probably they are in Latin letters. I don't know.
Yeah, the Lempel-Ziv dictionary will be very different if you use
So
alphabets.
my prediction is that it will not be caught if they use Lempel-Ziv, but it would be interesting to know whether it was or not.
There is a one-to-one correspondence between Latin and Cyrillic Serbian.
Yeah, but Lempel-Ziv, I'm not sure it can capture this, because when they construct a tree, they get a new tree.
So if you take a sequence of integers from 1 to 12, a long sequence, and compress it by Lempel-Ziv, and then apply some permutation and compress this new one, the difference will be significant.
No, they probably will give equally good compression, But if you compress a concatenation of them, I am afraid it will be more or less twice the length of compression of each, and so the distance will be large. That's what I am saying. No,
Oh, yeah.
distance,
So yeah. So
the distance will say that if a library constructed for your
you say
lectures,
if you take a long string in alphabet, say of size 10, and then copy this string and apply some permutations, then the resulting sequence will be compressed badly.
I think it will be just twice compressed, more or less. No, as far as I know, that's what I know about Lempel-Zip. Actually, B-zip is a different thing. They make a strange thing, which I don't see how it can help. But maybe for this,
maybe,
I'm not
but
sure.
I'm not sure even about Lempel-Zip. But maybe.
Okay, no, I would gladly make a bet because I read the paper about Lempel-Zip, and it's quite clear how the library is constructed. But anyway, don't worry. It's not important. Let's go on.
Okay, just another picture how Vitani has fun. He took several several English translations of Russian texts, and he used the same technology to construct this phylogenetic tree on Russian writers. And you see that text written by Gogol looks to be similar, the same for text written by Dostoevsky, but right here you can see some kind of mixture.
No, actually, it's not very. One should write also. There are translators, but they are not shown on the picture. So actually, I am afraid that books translated by someone could be more. For example, Russian books translated, English books translated by Chukovsky, I would suspect they will be more or less the same. No, but they didn't know.
But now 20 years later, we had this amazing talk 2 weeks ago about this complicated language model. So if we use them for compression, then the results will be even more impressive, I assume.
Yeah, but since the learning, I think the learning would be more or less independent for every language. So we also have to translate to compare the books written in the same language, even with this advanced thing.
But these deep neural networks, they can probably abstract through various grammars, since they can reproduce.
It would be very interesting if there are some students who understand this machine learning and can try to make such an experiment, have access to this model, and try to make.
Yeah, just a technical comment. You see the names of translators here in this caption for the diagram, and it seems that there are different translators for all these romans. Even the same author was translated, different books of the same author.
No, it's not important, but since you're saying this, for example, there is a Gogol which is quite close to Tolstoy Youth. Gogol «Мертвые души» и Tolstoy «Юность». And if you look, it's C.J. Hogarth who translated both. So it would be kind of interesting.
Yeah, in fact, it could be fun. Maybe not scientifically deep, but it would be funny to do this kind of experiments with the original texts. Okay, here Vitani not only can read, he only can know something about music, and here is this classification of composers. You see here is this cluster of Haydn. Here is another Haydn's songs. Here is Chopin, again Chopin. Here is Bach, and somewhere between Chopin and Bach there is Haydn. Okay. Yeah, one more musical picture.
And actually, the people who for people who may know this, I think this Chopin 15, which is in the middle, is just what is kind of water drops preludia, which is that's tam pa pam pam pam, and it's indeed quite in texture. It's not like typical Chopin, so it's not strange that it's more far from the cluster.
Yeah, but Bach is always Bach, and they're all far from Debussy. Okay, yeah. Here I think if I remember correctly, they used some compressor optimized for genetic sequences, and here they used it to construct this what really biologists would call this phylogenetic tree for different biological species.
Can we go to something mathematical now?
Okay, let us go to something mathematical. So here is a definition that we have seen. Here is the theorem that we have seen. And okay, since, you know, here we have, at least what Vitani is saying, that we seek some kind of clusters for similar objects. So let us go to mathematical definition of a cluster. So here is the main definition of our talk for today. So here is it's not merely okay. A definition. We're saying that a set of strings or a set of objects is a cluster with two parameters: diameter m and diameter m and size or log size L, if we have two properties. The first property, the first parameter m, diameter, it controls the distance between objects. So the distance between any two objects must be small. Okay, must be bounded by m. And the second parameter controls the size of the object. It must be rather large. And,
it cannot be more than 2 to the m. So this is just this when it's closed, then cluster is dense. Yeah.
Yeah. So formally speaking, it's a class. We have a definition of a cluster with two parameters: m, L cluster. And we're interested in a situation when m is approximately equal to the n. Yeah, indeed, L cannot be greater than m, or I don't know, m plus 1. And
because all the objects should be simple with respect to some fixed element of the cluster, so we cannot have more programs.
Yeah. If we have a bunch of objects which are clusters, all distances on pairwise distances are small. So now if I fix 1, then all objects are on the distance at most m from these single objects. So there are at most 2 to the m plus 1 of them. in all this set. And we're interested in a situation where M is close to L, as close as possible. Then we say that such a cluster is dense. Well, let me ask a question to the audience. Can you invent at least some example of a dense cluster where M is indeed quite close to the L?
You mean at least M over 2, L over 2?
Okay, as close as possible. Of course, you can take one point, one string, and you say that, formally speaking, as a cluster with a distance, I don't know, O of 1 and 0. But can you invent a cluster? So let us take some M. Can you invent a cluster with L as close
so
to M?
the set of all strings of length M. And so it's a cluster with diameter 2M and of size 2 to the power
Why
M.
2m? If strings of length m, then the diameter is m, because conditional complex. We don't sum the conditional complexities. We just take a maximum.
But if you take two independent random strings and their distance is
Maximum of
M,
c of
sorry.
x given I and c of y given x.
Sorry.
In general case, I mean, when n is larger than m, we should take all the strings with the same prefix.
Yeah, we can take we can fix the first, I don't know, k bits and take all extensions of length m, or maybe m a bit lesser than m minus constant, all strings like that. Then if we have two strings from this family, then to translate one string to another, what we need to do is just to give the new value of the tail of the second half of the string. So it's not greater than m. So the distance is m, and the size is just the number of all tails. It's also quite close to 2 to the m. So the difference between L and m is bounded by a constant.
You even don't need logarithm term, because you replace the place from the end and it's known where it is. So
And okay, it's not necessary to take the prefix. You can take the suffix, or you can use some other tricks. But you can use the following simple and naive idea. You take some, let us say, core z, and you can add to this core z